Okay, let's dive in. Picture this with me for a moment. The North Atlantic, it's vast, often shrouded in this perpetual cloak of mist and cloud.
Yeah, it's really something. Sunlight is often a rare luxury up there.
Exactly. Stars are often hidden, and fog can descend without warning, swallowing the horizon whole. It's just gray.
Totally. And now, imagine you're a Viking captain in a longship, centuries before modern instruments, miles from the site of land.
How do you possibly find your way across this unpredictable, featureless expanse? It sounds almost impossible.
Well, it is perhaps the most formidable challenge faced by the Viking navigators. Their entire way of life, trade, raiding, exploration, settlement, it all hinged on their ability to traverse these waters.
Right.
Yet, the very environment they sought to master frequently denied them their most basic navigational cues, the sun and the stars.
So the standard stuff just wasn't available a lot of the time.
Pretty much. Without them, conventional methods relying on celestial sightings, they just become useless. It presents what seems, from our modern perspective, an almost insurmountable problem.
Exactly. And they weren't just drifting aimlessly, were they? They were making deliberate voyages, crossing these open ocean highways for days or weeks at a time.
Heading for specific, relatively small targets like Iceland, Greenland, and eventually North America, Finland.
This wasn't just like hoping for the best. It required maintaining a course, finding direction when everything around you was gray and uncertain.
Absolutely. Precision was needed.
And this is where the legend whispers of a mysterious tool, something that sounds almost magical. The Viking Sunstone or Solarstein.
Yes, the Solarstein, a concept so seemingly fantastical that for a very, very long time, it was relegated purely to the realm of myth.
Just dismissed as, what, a literary flourish in the Sagas? Folklore.
Pretty much, yeah. Dismissed as just that, a magical element in a story.
But could this legendary stone have been something real? A piece of lost technology? Maybe. Potentially based on a brilliant understanding of natural principles centuries ahead of its time.
That's the intriguing possibility, isn't it?
Could it be the key that unlocked their incredible reach across the Atlantic? That's the core mission of this deep dive today.
Sounds good.
We're going to take the insights from the sources you've provided, looking at historical accounts, delving into the surprising science that suggests this could actually work.
Which is fascinating in itself.
Totally. And examining the modern experiments and archaeological finds that are kind of bringing this legend back into the realm of possibility.
It's a journey, really, from the misty pages of folklore to the cutting edge of experimental archaeology and even physics.
It's a truly compelling convergence of history, myth, and science. The idea that a simple crystal, a rock, basically, could solve such a complex navigational puzzle is just, well, it's fascinating.
It really is. So where should we start appreciating the scale of the problem?
Yeah, let's begin there. Let's fully appreciate the scale of the navigational problem the Vikings faced. We know they were phenomenal sailors, right? Experts at handling their ships.
Oh, without question. Their ship design was revolutionary, shallow draft, but incredibly seaworthy, capable of both coastal raiding and those long open ocean crossings.
And their basic navigation skills were highly sophisticated for the era, even without fancy tools.
Definitely. When the weather cooperated, they were absolute masters of observational navigation.
Meaning they used what they could see. Simple as that.
Precisely. Under clear skies, they'd use the position of the sun during the day, the stars at night, the pole star being a key reference in northern latitudes, obviously, and the phase and position of the moon.
Okay, standard celestial navigation, more or less.
Right, and they possessed this deep inherited knowledge of celestial movements built up over generations and generations of seafaring. It wasn't just casual observation.
And they could also navigate by coastline features when they were within sight of land, using mental maps or something.
Exactly. Detailed mental maps, or even early forms of written or rhyming directions passed down. Little poems or chance to remember routes.
And that works beautifully if you're sailing along the coast of Norway or making a relatively short hop across, say, a clear stretch of the North Sea.
Perfect for that. You can fix your position, maintain a heading, maybe even use a simple sundial or sun compass if the sun is actually out.
But their ambitions and maybe just necessity sometimes took them much further afield. Voyages from Norway to Iceland?
Yeah.
That's a big jump.
It is a journey of roughly 500 nautical miles over open ocean, and then the even longer stretches to Greenland, then onwards to Finland. These were entirely different beasts.
And in North Atlantic, well, anyone who sailed it knows it's notorious for its challenging conditions. It's not exactly the Mediterranean.
Not at all. That's putting it mildly.
So what specifically made it such a problem for those traditional methods? The sun, the stars, the coast?
Well, the frequency of persistent heavy cloud cover is a major factor. Days, sometimes many days, could go by without a single glimpse of the sun or stars.
Just gray day after day.
Exactly. Dense fog is also common, reducing visibility to near zero, making even basic visual cues like waves or the direction of swells harder to interpret reliably.
Right. You can't even see the water properly sometimes.
And crucially, in the high latitudes where they were sailing, particularly during the spring and summer seasons they often traveled, you have these very long periods of twilight.
Where the sun doesn't really set properly or doesn't get very high.
Exactly. Days where the sun is just below the horizon or skimming along it, providing very little direct light to sight by, even as it were visible through a break in the clouds.
Okay, so let's paint the picture. You're out there for days, maybe weeks, on the open ocean, and the sky is just a uniform gray. You can't see the sun, you can't see the stars. Your traditional guides are gone.
Yep, completely unavailable.
How do you possibly know if you're still heading towards Iceland or just, drifting aimlessly towards Greenland or maybe even back towards Norway?
That's the critical vulnerability in their system. It really is. Maintaining a course without being able to fix direction against the celestial bodies is almost impossible over long distances.
Small errors add up, I guess.
Hugely. Even a small error in heading, compounded over hundreds of miles and days at sea, means you could miss your target entirely, potentially disastrously. You run out of food, water.
Yeah, not good.
So for planned exploration, trade, or military action, this level of uncertainty would be completely unacceptable. You need reliability.
It really highlights the need for something else, doesn't it? A tool that could bridge this gap, that could provide directional information precisely when all other methods failed.
And this is the precise, critical gap that the legend of the Sunstone proposes to fill. It's the solution for those conditions.
A tool for the moments of greatest difficulty, those seemingly impossible navigation days. Okay, so where's this idea of a sunstone even come from in the first place? It's not like we found, schematics buried in a Viking longship.
No, nothing like that, unfortunately. The concept originates in the body of Norse literature, known as the Sagas.
Okay, the Sagas. Big narrative poems and stories.
Extensive prose narratives, actually. Largely written in Iceland centuries after the peak of the Viking Age, recounting the history, myths, and heroic deeds of their ancestors.
So part history, part story.
Exactly. While they are part historical record, part literature, and part mythology, they are our primary window into many aspects of Viking life and belief. We rely on them heavily.
And there's a specific story often cited as the origin of the sunstone idea, the one people always bring up.
Yes, the most well-known reference appears in the saga of Saint Olaf, or sometimes called the Saga of King Olaf.
King Olaf the Holy. He was a real person, right?
He was a real historical figure ruling Norway in the early 11th century, though, again, the saga itself was written down much later.
Okay, so what happens in the story?
The scene describes a moment when the weather turns foul. It's a cloudy, snowy day, visibility is poor, and the sun is completely obscured.
Okay, a perfect test case for this problem we've been discussing, the exact scenario.
Absolutely. Olaf, wanting to test his navigator, a guy named Sigurður, asks him pointedly, "Tell me, Sigurður, where is the sun right now?"
Like a trick question, almost. Because it should be impossible to know.
Exactly. It's presented as a challenge, one that should be impossible to answer accurately under those conditions.
And Sigurður's answer, what does he do?
Well, according to the saga, Sigurður reaches for his solarstein, his sunstone. He looks at the sky through it, holds it up, maybe rotates it, and is able to declare with confidence the precise location of the sun, hidden behind the clouds.
Wow. Just like that. He points and says, there it is.
Essentially, yes. This act convinces Olaf, demonstrating Sigurður's skill, possibly aided by this mysterious stone.
It's such a vivid image, isn't it? A single object allowing them to solve this impossible problem. But for centuries, as you mentioned, this is just seen as a magical element within a legend.
That's right. Why would a stone be able to do that? It sounded like pure fantasy.
In an age before the scientific principles behind such a device were understood, the saga's description must have sounded like, well, divine aid or outright magic.
Mm-hmm. It fit right in with the often mythological context of other saga elements. It didn't align with any known navigational tools or scientific principles of the time.
And our sources point out an important detail about the saga itself, don't they? About its age relative to the peak Viking Age. You mentioned it was written later.
Yes, that's a crucial point from the Vintage News article, and it's an important context. While King Olaf lived in the 11th century, the saga wasn't written down until centuries later.
Okay.
And the version often referenced, like the one interpreted by Longfellow mentioned in the source, is from the 19th century. That's really far removed from the period of intensive Viking North Atlantic exploration, which was roughly 900–1200 AD.
So does the fact that the saga is a later account diminish its credibility as evidence for the tool itself? Or just the story?
Well, it means we can't treat it as a contemporary eyewitness account of a sunstone being used in the Viking Age. That's
Yeah.
pretty clear.
Okay, fair enough.
But it is certainly strong evidence that the legend of such a tool existed and persisted in Norse culture for centuries. It shows that people believed or remembered that Vikings had a way to find the sun on cloudy days, and they associated it with a special stone.
So it proves the legend was real, but not necessarily the stone itself during the prime Viking era.
Exactly. Whether that tradition accurately reflects a tool commonly used by explorers in the 10th century, or if it's maybe a later embellishment, or perhaps a garbled description of something less magical, well, that's open to interpretation.
Right. It shifts the evidence from direct historical record of use to evidence of a deeply held belief or tradition about a navigational type ability.
Precisely. It provides the folklore, the story, the idea, but not necessarily the physical proof, or, crucially, the scientific explanation.
And that scientific explanation is what really brings the legend back into focus hundreds of years later, right? When science catches up with the folklore.
Absolutely. This is where modern science intersects with ancient folklore in a really cool way, transforming the sunstone from a magical artifact into a potentially plausible technology.
And the key lies in understanding the properties of light and certain crystals.
That's it. It all comes down to light.
Okay, let's get into that science. What allows a crystal to potentially find a hidden sun? What's the trick?
Okay, so the primary principle is something called polarization of light. It sounds complex, but the basic idea isn't too bad.
Go on.
Think of light waves not just traveling forward, but also vibrating. Up and down, side to side, all directions perpendicular to its path. That's normal, unpolarized light.
Okay, vibrating everywhere.
Right. But when light interacts with certain materials or passes through certain environments like our atmosphere, these vibrations can become restricted to specific directions or planes. That's polarization. The light waves start vibrating more in one direction than others.
And the atmosphere does this to sunlight.
Yes. Crucially, sunlight. As it enters and scatters through the Earth's atmosphere, bouncing off air molecules and tiny particles, it becomes polarized.
Okay.
And the degree and direction of this polarization aren't random. They form a distinct pattern across the sky, a pattern that is centered on the actual position of the sun.
Even if the sun itself is completely obscured by clouds or fog.
Exactly. Even on a uniformly gray day, there's an invisible pattern of polarized light that holds the secret to the sun's location. It's still there, you just can't see it with your naked eye.
Whoa. It's like an invisible target painted on the sky, centered on the sun. But how do you see or detect this invisible pattern? That's where the special properties of the crystal come in.
Exactly. This requires a material with a property called birefringence. It sounds technical, but it just means double refraction.
Double refraction, okay.
It's a property found in certain transparent or translucent crystals. When a beam of light enters a birefringent crystal, it gets split into two distinct beams.
Two beams from one.
Yep. And these two beams travel through the crystal along different paths and at different speeds.
Is that why sometimes if you look through certain crystals, things look doubled?
Precisely. That's a common manifestation of birefringent seeing double, like with Iceland spar, a type of calcite.
Okay.
But the crucial part for the sunstone concept is that these two split beams are also polarized. And importantly, they are polarized at 90 degrees to each other, perpendicular.
Ah, okay. So you have polarized light coming from the sky's pattern, and you have a crystal that splits light into two beams, which are also polarized but at right angles to each other.
You got it.
So how does putting those together reveal the hidden sun? How does that work?
This is the clever application. A navigator using a birefringent crystal would hold it up to the sky, say, towards a patch of brighter cloud, and slowly rotate it while looking through it.
Just turning the crystal.
Yes. As the crystal rotates, the two polarized beams of light that pass through it interact with the polarized light coming from that patch of sky.
And how do they interact? What does the navigator see?
The key is how the brightness of the two split beams changes as the crystal is rotated. Because the crystal splits light based on polarization angle, and the sky's light is also polarized in a specific pattern.
The brightness changes depending on how they line up.
Exactly. There will be certain orientations of the crystal where the two beams appear distinct in brightness. One might look brighter, the other dimmer.
So you're looking for a specific point in the rotation.
Yes. There are specific angles of rotation where the crystal's own polarization axes align precisely with the polarization plane of the light from that part of the sky.
Okay, the sweet spot.
Right. When this alignment occurs, depending on the method used, maybe you're looking for the point where the two beams appear equally bright, or perhaps the point where one beam disappears or appears darkest. The navigator can identify the plane of polarization of the incoming light for that spot in the sky.
And how does identifying that plane tell you where the sun is? That seems like another leap.
Well, because the sky's polarization pattern is mathematically linked to the sun's position. Remember those invisible circles of polarization centered on the sun?
Yeah.
The plane of polarization you detect at any point in the sky is tangential to the imaginary circle passing through that point. So, by finding this plane...
You know the direction of the circle.
Exactly. And by finding the orientation of this plane, maybe by checking a couple of points in the sky and knowing roughly your position and the time of day, you can deduce the center of that pattern, the sun's location.
So you might have to look around the sky a bit, rotate the crystal at different points.
Potentially, yes. A navigator might use this to find the direction where the light is polarized, say horizontally or vertically relative to the horizon, and extrapolate from there. Or they might move the crystal around the sky until a specific pattern of brightness appears across the two beams. The point is, the crystal makes the invisible pattern visible through the differential brightness or intensity of the two split beams.
Wow. So by simply rotating this crystal and watching how the light behaves, you can map the sky's polarization pattern and pinpoint the sun's direction, even if it's completely obscured behind thick cloud or fog.
That's the theory, and it's scientifically sound.
That is a brilliant piece of observational physics applied practically centuries before anyone wrote down the equations for polarization.
It is. It's quite remarkable. And the sources mention specific crystals that fit the bill and were actually available to the Vikings in Scandinavia and the North Atlantic.
Which ones?
Calcite, in its clear form known as Icelandic spar, is a prime candidate. It's got strong birefringence and, well, it's found in Iceland, a key Viking location.
Makes sense. Cordierite,
sometimes called Iolite, is another possibility. Also found in the region, like Norway and Greenland. It has a slightly different property, sometimes called dichroism or trichroism, where it appears different colors depending on the viewing angle relative to the light's polarization. That could also be used.
So color changes instead of just brightness?
Potentially, yes. And tourmaline is also mentioned as a possibility, another birefringent mineral.
But Icelandic spar, the calcite, is often highlighted because of its clarity and strong double refraction. It makes that brightness difference really obvious.
Exactly. Its optical properties make it particularly well suited for this specific task of comparing the brightness of the two beams. It gives a very clear signal.
So the science confirms that the fundamental principle is sound. A birefringent crystal could theoretically be used to detect the hidden sun's direction via sky polarization.
Absolutely. The physics works out.
But as we touched on earlier, scientific plausibility is not the same as historical reality. Did Vikings actually use them? Did they figure this out and apply it?
That's the million-dollar question, isn't it? That's the critical next step, finding the evidence beyond the sagas and the physics.
And this is where modern researchers have taken the scientific principles and the saga accounts and tried to bridge that gap, trying to prove it.
Precisely. The search for evidence has taken two main forms. Experimental archaeology, basically trying to replicate the potential tool and its use.
And traditional archaeology, looking for physical artifacts, the actual sunstones.
Exactly. Both lines of inquiry are crucial.
Okay, tell me about the experimental work first. The sources mention a notable experiment back in 2011. Sounds pretty important.
Yes, that was a significant step forward. It was conducted by a team led by physicist Guy Ropars at the University of Rennes in France. Their goal was basically to test the practical feasibility of using a calcite crystal for this purpose. Could it actually work well enough?
And what did their setup look like? Did they just hold a crystal up?
They were a bit more systematic. They used a calcite crystal, likely a piece of Icelandic spar, and mounted it within a wooden frame, kind of like putting it in a little box.
Yeah.
They created a small aperture, like a hole or pinhole, in the wood that light would pass through before hitting the crystal. This setup projected the two split beams of light onto a surface inside the box, making it easier to observe and measure the brightness difference accurately.
Ah, so they built something like what a Viking might have fashioned, a functional model.
A functional model, exactly,
Yeah.
designed to test the principle in a controlled environment. wasn't necessarily an exact replica of how a Viking tool might have looked or been used. We don't know that, but it allowed for precise measurements of accuracy.
And they conducted tests on land, looking at the sky through this apparatus, even when the sun was obscured.
Yes, under various conditions, including cloudy skies.
And what were their results? How accurate was it? Did it work?
The results were very impressive, and they were published in a top scientific journal, the Proceedings of the Royal Society, which adds a lot of weight. Ropars and his team found that using their calcite crystal setup, they could determine the sun's polarization direction with remarkably high accuracy. The sources note they were able to get readings that were only about 1% out from the actual solar meridian.
Only 1% error. That's incredibly precise. That's definitely more than accurate enough for long-distance navigation over open ocean.
Absolutely. 1 degree of accuracy, roughly. It demonstrated definitively that the scientific principle worked in practice and that a birefringent crystal could indeed function as a highly accurate sun compass surrogate, even without a direct view of the sun.
So strong practical weight added to the theory. It's not just theoretical physics anymore.
Exactly. It showed it was feasible and effective.
That's powerful evidence for the how. But what about testing this principle under conditions maybe closer to a real voyage, at sea over time with a moving ship?
Right. That's a fair question. And that's where a more recent study mentioned in the sources comes in the work by Denis Saz and Gabor Horvath from Iolite Adolphus Lorand University in Hungary. They took a different approach.
How so?
They used computer simulation, very sophisticated computer modeling.
A virtual sunstone voyage? Seriously?
Essentially, yes. They built a complex computer model to simulate Viking voyages across the North Atlantic. This simulation included all sorts of realistic factors: weather patterns, cloud cover variability over time and location, the movement of a ship on the waves, and a virtual navigator attempting to use a sunstone to stay on course.
Wow. Why use a simulation instead of just, getting on a boat with a crystal?
Well, a simulation allows you to run thousands upon thousands of trials under a vast range of conditions that would be incredibly difficult, time-consuming, and expensive to replicate in physical experiments at sea.
Right, you can test way more scenarios.
Exactly. They can simulate days, weeks, even entire voyages from Norway to Greenland, for example. They could test the accumulated error over long durations and through varying degrees of cloud cover, from just partial clouds to complete overcast for days on end.
And they could get statistics on success rates.
Precisely. They could statistically analyze the success rate of navigation using the crystal across all these different runs.
How many times did they run this virtual voyage? You said thousands.
They ran the simulation a staggering 36,000 times. 36,000 simulated voyages.
Whoa, that's thorough. That provides a massive data set to assess the reliability and accuracy under realistic simulated conditions.
Absolutely. It gives you real statistical power.
And which crystal did they focus on in this simulation? Calcite again?
They primarily focused on cordierite, or Iolite, that other candidate crystal we mentioned, which is also found in Scandinavia and Iceland and has those useful birefringent properties.
Okay, testing another possibility, and their findings. Also published in a peer-reviewed journal, Royal Society Open Science. What did 36,000 virtual voyages show?
Their results strongly supported the effectiveness of cordierite. The simulation showed that navigators using a virtual cordierite crystal could maintain a course with impressive accuracy.
I'm impressed.
They were achieving success rates for reaching their destination, like hitting Greenland from Norway in the 90 to 100% range, even through extended periods of poor visibility simulated in the model.
90 to 100% accuracy. In a simulation running 36,000 times through realistic maritime conditions using cordierite. That's incredibly compelling.
It really is. It suggests that, at least in the simulation, cordierite was a highly effective tool for the job.
So taken together, both the physical experiment with calcite and the extensive simulation with cordierite seem to validate the scientific principle and its practical application for navigation in challenging weather.
They certainly do. The scientific and experimental evidence is stacking up strongly in favor of the possibility and effectiveness of the sunstone concept. It looks like it really could have worked.
However, there's always a however, isn't there?
There often is in historical research. The final piece of the puzzle, and the one that remains frustratingly elusive, is the definitive archaeological artifact, the smoking gun.
Right. Have archaeologists ever actually found a crystal dated conclusively to the Viking Age in a Viking context, like a shipwreck, a grave, a settlement that could be clearly identified as a sunstone?
That is the key missing piece for absolute certainty. And as of now, the answer is basically no. There has been no definitive discovery of a birefringent crystal, clearly identified as a navigational instrument, found within a Viking Age context that screams, this was a Viking Sunstone.
So no crystal labeled property of Eric the Red.
No, nothing quite so convenient. We find lots of Viking artifacts, but not this specific thing yet.
But there was one interesting archaeological find mentioned in the sources that, while not actually Viking, significantly changed how researchers thought about the Sunstone idea, right? Softened some of the skepticism.
Yes, exactly. The discovery in 2002, often called the Utrecht find, after the ship's name, the Alderney. Archaeologists were excavating the wreckage of an Elizabethan English ship.
Elizabethan. So Shakespeare's time.
Right. It sank off the coast of Alderney in the English Channel in 1592. And among the artifacts recovered was a calcite crystal, described as somewhat opaque, but definitely calcite, found near other navigational instruments like dividers.
Okay, so this was an English ship, late 16th century, centuries after the main Viking Age. Why was finding this crystal so significant then?
Its significance lies in demonstrating that birefringent crystals were actually being carried and potentially used on ships engaged in serious maritime navigation, even in a later era when other tools like compasses were well established.
So it proved the concept wasn't just theoretical or legendary.
Exactly. Before this find, the Sunstone was largely dismissed by many as pure fantasy. Finding this crystal on a ship from a period when navigation was becoming increasingly sophisticated suggested that the idea or practice of using crystals for navigational purposes, perhaps for finding the sun or maybe checking compasses, was real and persisted.
Maybe independently developed, or perhaps passed down in some form.
That's the question it raises. Could this be a case of the idea persisting or being adopted later? Or was it a separate, later innovation? The Utrecht find provided a tangible example of such a crystal on a working ship.
So it changed the perception from impossible magic to plausible historical tool, even if it wasn't a Viking one.
Precisely. It serves as important circumstantial evidence that this type of tool could have been part of a navigator's kit. But, crucially, it doesn't directly link it to the Vikings themselves.
It just supports the concept as real maritime practice. But the Viking link remains theoretical, supported by the sagas, the science, and the experiments, but still awaiting that physical artifact from the right time and place.
That's the situation perfectly summarized. The evidence is strong and circumstantial, making a compelling case, but the absolute certainty requires that smoking gun artifact from a Viking context.
Okay, so let's put this potential sunstone in perspective then. Assuming for a moment the Vikings did widely use this tool, how would it have fit into their broader navigation practices? It wasn't the only thing they used, surely.
Oh, absolutely not. That's a really important point. As we discussed earlier, the Sunstone wouldn't have been their only navigational aid. It would have been one crucial tool within a comprehensive toolkit of methods.
A whole bag of tricks.
Pretty much. Each tool or technique suited to different conditions and different stages of a voyage. They were adaptable.
Like a specialized tool for a specific problem. The sunstone was for the bad weather days.
Precisely. In clear conditions, they would rely heavily on direct celestial observation, sun, stars, moon, perhaps aided by a sun compass, which we know they had.
What was a sun compass exactly?
A simple wooden disc, basically, with markings. It used the shadow cast by a central pin, an omen, to track the sun's movement across the sky during the day. By comparing the shadows past to known curves for different times of year, they could determine north and thus other directions quite accurately when the sun was visible.
Okay, so that worked well in sunshine.
Very well. And they relied heavily on accumulated knowledge passed down through generations of sailors. Experience was key.
You mentioned the oral traditions, the rhymes and narratives.
Yes, those were incredibly important. Navigational knowledge was codified in these memory aids versus describing routes, landmarks to look for, sail towards the big pointy mountain, sea depths, currents, and directions between known points like 2 days sail west from Bergen gets you halfway to Shetland. Vital for dead reckoning between sightings.
And they were keen observers of the natural world too, right? Using environmental cues.
This was a massive part of it. They'd pay incredibly close attention to the flight patterns of birds. For example, knowing that certain land-based birds, if seen far out at sea after leaving the Faroes, probably indicated that Iceland was relatively close, because those birds wouldn't venture that far from land.
Clever. Like using birds as living signposts.
Exactly. They'd listen to the sounds of waves, how they reflected off unseen land or ice. They could smell the presence of land or specific types of water, like freshwater outflows from rivers mixing with the sea. They'd observe subtle changes in ocean currents or the direction and shape of swells.
Just using all their senses.
Yeah.
And reading the weather itself must have been critical too, surely.
Oh, essential. Understanding cloud formations, predicting approaching storms, reading wind shifts. This would inform their decisions on heading, when to seek shelter, and generally ensuring the safety of the ship and crew. These observational skills were honed to a fine art over centuries.
So with all those other methods, where does the Sunstone fit in this picture? Why was it potentially so important?
It fits in as the vital piece that completed the puzzle for long-distance open ocean navigation, specifically under adverse conditions.
The missing link?
Kind of, yeah. All the other methods, celestial environmental cues, dead reckoning from known points, they could falter or become completely impossible during those prolonged periods of heavy cloud cover or dense fog that are so common in the North Atlantic.
Right. Birds might not be around. You can't smell land from 200 miles out.
Exactly. The Sunstone, by potentially allowing them to find the sun's direction through the overcast, provided the crucial ability to maintain a deliberate course even when effectively blinded to the sky. It filled the gap.
It was the potential tool that made consistent, targeted Atlantic crossings feasible, bridging that critical gap left by traditional methods in bad weather.
That's it, precisely. It connects the dots for how they managed those incredibly long and difficult voyages repeatedly.
So it's not just a tool, but perhaps the tool that really elevated them from being primarily coastal raiders and short-hop sailors into true masters of the high seas, capable of deliberate transatlantic colonization and trade.
That is the significant implication, yes. If sunstones were indeed widely used, it profoundly impacts our understanding of Viking capabilities and the drivers behind their remarkable expansion across the North Atlantic.
How so? What does it mean for how we view their history? What changes?
Well, fundamentally, it elevates their navigational prowess significantly beyond what was previously assumed, especially back when the Sunstone was considered mere myth.
We thought they were just tough and lucky.
Maybe a bit of that, yeah.
Yeah.
But this suggests a level of sophistication and technical understanding, albeit empirical, based on observation and application rather than formal scientific theory that was really remarkable for the time.
It makes their voyages to Iceland, Greenland, and Vinland seem less like incredibly lucky drifts or just hugging coastlines they couldn't see, and more like deliberate, calculated acts of exploration, enabled by effective, if perhaps complex to use, technology.
Precisely. It helps explain the scale and the consistency of their activities in the North Atlantic. How could they establish and maintain settlements in Greenland for centuries? Settlements that relied on regular resupply voyages from Norway across notoriously difficult waters.
Good point. That requires reliable navigation.
How could they trade consistently across these vast distances? How could raiding parties plan and execute attacks on distant, specific targets like monasteries in Ireland or Britain, involving voyages of hundreds of miles over open water, and reliably find their way back?
The Sunstone provides a plausible mechanism for maintaining the necessary accuracy over such distances and under the prevalent weather conditions. It makes the logistics make more sense.
It really does. It paints a picture of Viking ingenuity that goes beyond the well-known aspects of their culture, like their amazing shipbuilding or their military tactics.
It shows a different kind of intelligence, maybe, an ability to observe subtle phenomena in the natural world.
Like the way light is polarized by the atmosphere, the peculiar optical properties of certain crystals found in their environment.
And turn that observation into a practical, life-saving, and ultimately civilization-enabling technology, without needing the mathematical physics first.
Exactly. It's a testament to their practical science, their sharp observational skill, and their ability to innovate using the materials and knowledge available to them. The potential widespread use of the Sunstone showcases a different kind of brilliance.
One focused on solving fundamental challenges of survival and expansion using natural principles, centuries before those principles were formally understood and documented by science.
Well said. It highlights this deep connection and understanding they must have had with their environment.
Okay, so let's bring this deep dive to a close. We started with a compelling legend from the Sagas, a story that for centuries sounded like pure fantasy, a stone that could find the sun through clouds.
We then explored this surprising scientific reality, the principles of light polarization and birefringence that provides a perfectly plausible, elegant explanation for how such a tool could actually work. The physics is real.
And we looked at the modern evidence stacking up. The physical experiment showing a calcite crystal can pinpoint the sun's direction with high accuracy.
And the massive virtual simulation demonstrating the reliability of a cordierite crystal for navigation over long distances and challenging North Atlantic conditions. Thousands of successful virtual trips.
We also noted the intriguing, though not definitive, archaeological discovery of a calcite crystal on a later Elizabethan ship, suggesting the concept of using crystals for navigation was indeed part of maritime practice.
Putting all this together, the weight of the evidence, the consistent legend, the sound science, the successful modern experiments, and that later archaeological hint, it makes a powerful case.
So while we still lack that final concrete Viking Age artifact, the smoking gun crystal from 950 AD.
The Sunstone, the solar shine, is now considered by many researchers, perhaps most, to have been a real, effective, and likely crucial navigation tool used by the Vikings, especially for those challenging ocean crossings.
It transforms a piece of intriguing folklore into a remarkable example of ancient ingenuity and practical scientific knowledge. It really highlights how much we are still learning about the capabilities of past cultures.
Yeah, absolutely. It truly exemplifies how the Vikings didn't just endure the unforgiving environment of the North Atlantic, but how they mastered it, using everything at their disposal, including, perhaps, the subtle properties of light itself.
It truly does. It's a story that combines the thrill of discovery with the elegance of physics and the incredible achievements of human exploration and adaptation. Really makes you think. So, here's a thought for you to carry with you after this deep dive. If the Viking Sunstone, this seemingly magical stone from legend, turns out to have been a real, practical scientific instrument based on principles not formally understood for centuries, what other pieces of lost technology or forgotten practical knowledge might be hidden within the stories and practices of ancient cultures around the world?
That's a great question. What other magic from folklore might actually have a basis in observable practical science that we just haven't figured out yet?
Exactly. What other secrets might be waiting to be rediscovered, perhaps not in laboratories with complex equipment, but simply by looking at the natural world with the same keen, observant eyes that the Vikings or other ancient peoples might have used?
It makes you wonder how much innovation was simply passed down through practice and observation, maybe embedded in rituals or stories, never written in formal scientific treatises.
And how much of that invaluable knowledge might still be out there, waiting to be found in folklore? Or maybe rediscovered through careful study of the natural world itself, perhaps through ethnobotany or experimental archaeology.
Yeah, it suggests we should pay closer attention to those old stories and traditional practices.
Exactly. The Sunstone is a powerful reminder that the past still holds mysteries, and that even the simplest seeming natural objects, a clear stone, a specific plant, the flight of a bird, can contain complex scientific keys if you know how to look. What else have we overlooked?